Hi, today I will be talking about a few topics from the Black Swan book, written by Nassim Taleb. Basically deals with unexpected events and how we as humans kind of ignore these outrageous outcomes, and we basically look back on it and try to rationalize those things so that we can predict in the future. And my topic is games versus reality, how we kind of use models from games to predict real life situations and how that's a terrible idea. And then I'm going to go into Bayesian versus frequentist approach and how these kind of problems affect both sides. So let's go into games versus reality. So he, in one of his chapters, explains the difference between probabilities in games and in reality. So these two quotes I thought were really useful in kind of deciphering the difference. So he says that casino is the only human venture I know where the probabilities are known. So Gaussian or normal curves, and also computable. So if you were playing roulette and you wanted to find the probability of black on a single roll, that probability you can compute. But in real life, you don't know the odds. You have to discover them, and the sources of uncertainty are not defined. So essentially, he's saying that these game simple basic models translated into real life situations do not work whatsoever, and they need to be used very cautiously, and the assumptions that we use need to be held, or these models are basically useless. So I guess so I mean, his whole kind of idea was to avoid the ludic fallacy, and I'll go into what that is on the next slide. So what is ludic fallacy? It is the actual definition is the misuse of games to model real-life situations. So it's kind of like what I've been talking about on the last slide, and a few examples of ludic fallacy. So one of them he used in his book called The Coin Toss. I thought it was really interesting. He basically says there's a mathematician and a gangster. So someone comes up to both of them. He says, assuming this coin is a fair coin, given I've flipped the coin 99 times and it came up heads all 99 times, what's the probability that it comes up heads on the next toss? Well, the mathematician says, assuming independence, assuming it's a fair coin, I'll say 1/2. And the gangster goes, well, you got to be crazy to believe that that's a fair coin. If it's a fair coin, how are there 99 heads in a row? The odds of that happening are basically zero. So it's a ludic fallacy. It's an example of ludic fallacy because he's looking at the assumption first. He's saying that the assumptions are basically wrong and that there's no way that 99 heads could have happened in a row. So this is kind of what we need to look out for in real life situations. We need to look at the assumptions and say these assumptions don't hold. This model is not going to work in real life situations. And the other one is algorithmic trading, especially just the stock market and how we think we can predict the stock market using past values. But just like the 2008 crash, we had sophisticated models, probably bell-like shaped models that were trying to predict the market, and those, all of the models did not predict the crash in 2008, and that's why a lot of people lost a ton of money. So I guess this is another example of ludic fallacy because we cannot predict the stock market with basic models because stock market is real life, it behaves erratically. You can't predict it with a model. So that was games versus reality. One uses simple models, the other one you cannot. So now I'm going to go into how I guess this ludic fallacy affects the Bayesian versus frequentist approach to analyzing data. So before I go into that, I'll just explain what the differences between the two are. So one can, first let's go into what Bayesian analysis is. So we basically take data, current data, and prior information, whether that's given to us from an expert in the field, or whether that's data from a previous from previous analysis, and we combine the two, and it gives us a posterior distribution for our parameters. So in this case, our parameters are considered random and come with distributions. So the mean will come with the distribution. It'll come with the center, which is the highest likely value of the mean, and then it'll also come with how a width of the curve depending on how certain you are about your guess. And it's different from a frequentist point of view, where a frequentist, he thinks these parameters are fixed, the mean is fixed, you get one value for the mean with the standard deviation, and you get no curves, no prior distributions come with it. So now let's kind of take a look at how these might be affected. But before I do that, I kind of wanted to introduce Medio-Christian and Extremistan ideas, because these kind of play a role in data analysis. So Medio-Christian is a domain where the outliers have little impact on the total, such as weight or height. Imagine you have 1,000 people and you're just taking their weights and you're adding them up. You could have someone who is a tremendous outlier, say weighs 500, 600 pounds, and everyone else's average, you add up the total weight, that one outlier guy is not going to affect the total really at all if you have 1,000 people. But from an Extremistan point of view, a single observation can disproportionately impact the total, such as wealth. So if you have 1,000 people, and say 999 of them have net worths that total $1 billion. So say they're about $1 million each, and you have $1 billion between the 999 people. And then you take Bill Gates as the 1,000th person in your study, and you add his net worth in. Say his net worth is 50 billion. I'm not sure what it is, but say it's 50 billion. You add him in, that's 51 billion. He single-handedly accounts for about 98% of the wealth in that total. So these are the kind of the two differences between Extremistan and Medio-Christian. So he goes into the impacts of both here. So how does the Ludic fallacy come into play? So from a Bayesian approach, you cannot estimate the unexpected events in the priors, right? So if you have Bill Gates in your sample, you're trying to make a prior distribution. The prior distribution is going to be all out of whack because it cannot account for that one extreme outlier. It can only account for the others. Then you take the data, add it with the posterior. Now the posterior is going to be useless because the prior was useless. And maybe in your data you got some extreme outliers that you don't know what to do with. So when you analyze your data, you're using Medio-Christian tools, essentially, that can't really handle big values, and you're creating something that's going to be a complete lie, right? Because if you have one extreme outlier, you're finding some curve. The curve's going to be shifted probably way to the right because of the outlier, so all of a sudden your average is way above what your real average should be, so that curve is useless. And he does a great job here. I like this quote that I pulled from the book. He says, consequently, if we're in the domain of Extremistan, and we use analytical tools from Medio-Christian for prediction, risk management, etc., we face enormous surprises. Some of these surprises may be positive, some may be negative, but their impact will likely exceed what we were prepared for. So again, if you're using Medio-Christian tools, you're not really expecting outliers, such as I talked about earlier in the 2008 housing crash. We're probably using Medio-Christian tools. We weren't expecting a crash, so the tools, the curves we were coming up with, the models we were creating, did not expect a crash. But what happened? The market followed the domain of extremism. Boom, the crash happened. Our models couldn't predict for it, and disaster basically struck. And that's probably what happened in the stock market crash, like Black Friday in the 20s also, and also the crash in the 90s as well. So it's just something to be aware of. So I guess the conclusions of this is that games are games, and they shouldn't be used outside of where they're played. Right? Games have their simple models because you can calculate probabilities. You can calculate the extreme probabilities because you know all the outcomes. In real life, you don't know all the outcomes. Right? That's kind of the whole idea of the black swan. Right? Before we saw the black swan, we didn't even know it existed. We assumed all swans were white. Boom! Here comes a black swan. The probability of a black swan was 0 essentially. Right? So the same thing in real life situations. The probability of the market crashing in 2008 was probably 0, and it crashed. And I just pulled a cool little quote from his book. It says, "This building is inside the Platonic fold. Life stands outside it." He was at a convention. He was at like a military security of defense kind of convention, I guess you could say, at a casino in Las Vegas. And he was just talking about how it's the worst place to hold an event like this. And they were talking about probabilities in real life and in defense, in terms of military defense. And he was just saying how simple models should be left for games, not for real life situations. And I just for here, the perfect curves that we use and see in school do a terrible job predicting unexpected events and tales, especially in extremist cases, i.e. the housing crash 2008, and I guess always considered unexpected. All right, thank you.